Hi, we are going to talk about the properties of multiplication right now. And if you need a refresher, I think it would be a great time to pause this video and look about the video of properties of addition. Because they're pretty much the same thing, but just a tweak different. Okay? As simple as they are, and as forgettable as they are, and as duh as they are wildly important in moving forward. Because when things become more complicated, you need to rely on these basic truths. And a lot of students just don't because they're just, I don't know, uncomfortable or whatever. If you got a little old, I think it got burned. Okay, there are three properties: commutative, associative, and the identity. Commutative and associative, I always switch around, but I'm going to get it right this time. So commutative is, we'll just give an example. Well, we'll do the super mathy version so you can feel real smart. A times B times C can be A times B times C or A times B times C. What that just means is if I have 2 times 3 times 5, I can multiply these in any order. The same way we did with adding. So 2 times 3 is 6, times 5 is 30, right? 2 times 3 times 5, 3 times 5 is 15. 2 times 15 is, you betcha, 30. Can do one more way over here. 2 times 3 times 5 can be switched because of the associative property, which we'll get to 2 times 5 times 3, and 2 times 5 is 10, times 3 is, what? 30. Okay, it doesn't matter the order. Let's go back to the associative property because we totally used it in the commutative property. A times B is the same as B times A. Or 5 times 3 is the same as 3 times 5 is the same as 15. Properties super duper 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 important. And then the identity. This is where we need for algebra. So if you remember, the identity under addition is 0. What can you add to any number and still get the same number? So the identity under addition is 0. And when you have equations, there are phantom zeros all over the place, added and subtracted because you don't write it. Same is true with this fancy number. So let's think. Under multiplication, what is a number that you can multiply to any number and still get that number? So, for example, 8 times something is equal to 8. What is that something? Well, under addition, the identity was 0. But what happens if you put 0 in here? 8 times is 0. What that's saying is, because remember, multiplication is batched addition, you're saying I'm adding 8 to itself no times. I am not adding 8. That means you started where you were, which is 0. So 8 times 0, or 8 0 times, is 0. Anything 0 times is 0. But what if we want 8? How many times have we counted 8 to get 8? The identity under multiplication is 1. Anything times 1 equals itself. That's why it's the identity. I look in the mirror. I'm looking at the man in the mirror. Oh yeah, it's that kind of a day, okay? So I am asking him to change his ways, but I want to know what he looks like also. That would just be if it's, you'd say, if it's under addition, then my man in the mirror is 0. I'm adding 0 to myself to look at myself. And if it's under multiplication, it's 1. Okay? So, how does this manifest? We're at 5 minutes. I'm going to give you an example of why this is important. Because this goes for division as well. Because I don't know if you know this, but future Becca, or past Becca, had to call on me to make this video as an insert. Okay. 8 can be the same as 8 times 1. We can leave it that way. 8 can also be written as 8 divided by 1. We have divided it 1 time. So this idea is super important. So let's think about this for a second when we think about multiplication and division. Let's say I have, choose the bad number to start with. I'm going to start with 3. 3 times 7/6. That's still going to give us a fraction. Can you tell I'm trying to not get a fraction? But if I make it an even number, it's just going to be the same. Well, we'll go with 5/3. Okay. Now, we could say 15/3 and then do the division and say that's 5. But we can also do this. This is the same as 3/1 times 5/3. And that is the same as, because of the associative property, now I'm going to put it all under the same fraction bar. Okay. I can switch this because of the associative property. 3 times 5/3 times 1. 3/3 times 5/1. And any number over itself. I have 14 people and I have 14 pieces of candy. Everybody gets 1, right? 1 times 5. And that's 5. You may have seen this right away, right? 5/3, 15/3, right? But knowing how it switches through using the properties can make you do math really quickly in your head. I suppose I should let this sit on this thing for a while. You need to write that down. So these are all equal to each other. But if you're looking for a whole number, that's where that would come in. This is a funky dunk 5 down there, isn't it? There you go. That looks like 15, but it's 1 times 5. Oh, all the symbols matter. So, my bad coffee aside, those are the properties you're going to need. Okie dokie. So, there are some examples coming up. Finally introduce, I think we can wait on exponents because variables can just come in now. Okie dokie. Stay safe. See you later.